Hey everybody, I'm really sorry that I have to be out today, but you're in good hands. Ms. Polton has done this experiment already twice, so she knows what's going on. If you want some extra assistance with mini lesson, that's what I'm here for right now. So hopefully during bridge you found that, yes, you can determine that that compound that I put on your desk, that mixture actually, was an acid. But what you can't tell is A, exactly what acid it is, or B, how concentrated it is. So when we're dealing with acids and bases, there's some general stuff we need to know, but then there's also some calculation work that we can do to figure out exactly how concentrated our acid might be. So you guys remember the pH scale. It goes from 1 to 14, and our neutral 7 is right in the middle. Acids fall on the low end of the pH scale, so between 1 and 6.999999999. Bases, of course, take up the other half of the scale. And what's interesting, that acid was actually hydrochloric acid, and hydrochloric acid's pH is somewhere in between 1 and 2. So if we call it 1, and we compare the pH of hydrochloric acid to the pH of vinegar, which is about 3, we're going to find, yes, you can put vinegar on chips and eat it without any issue. Hydrochloric acid on chips wouldn't be so great. Why not? Well, each jump on the pH scale represents a 10-fold increase or decrease in the amount of H+, or the level of acidity. So if we're going from 3 to 1, we've got to make 2 of those jumps. 10 times 10, which is going to be 100 times more acidic than vinegar, a pH of 1. That's a lot of acid. And like we said, kind of mentioned, the idea of being more acidic just means having more H+, the ion that makes acids acids. So acids are associated with H+. You may also see H+ written as hydronium or H3O+. Exactly the same thing. It just says it's in water and it happens to form this H3O+. But whenever you see H3O+, you can just think in your head H+. Bases, on the other hand, have to do with the OH- ion. And it's the same rule that applies to bases when we compare, let's say, a pH of 7 to a pH of 9. If we move in this direction, we're getting 10 times less acidic each jump we make, so 100 times less acidic, which means less H+. And if you notice, on your list of common bases on table L, NH3 is listed as a base, even though it doesn't have OH- in it. And there are some folks that recognized that earlier in chemistry, a history of chemistry, I guess, and they had to come up with a different theory or definition of what acids and bases were to account for that fact. And here's what they came up with. The first thing is pretty easy to remember. Acids are H+ donors, which is to say that they give off H+. Well, great, that matches our first definition exactly, so that shouldn't be too hard to remember. According to this alternate theory, acids are H+ donors. Bases are kind of the opposite, right? But to account for the fact that not all bases have OH-, we just call them the opposite of acids. So instead of donating H+, they accept it or take it. So we call bases H+ acceptors. Because if they're taking H+ out of the water, or out of the solution rather, it must be getting less acidic or more basic. So we've got H+ donors as acids, H+ acceptors as bases. This is just one of those definitions that you need to memorize because it shows up on the Regents exam every year, this alternate theory of acids and bases. So pause now if you have any questions and get those addressed on just the general properties of acids and bases. Side note, before you do pause that, remember, table M, those indicators, you probably use bromothymol blue during your bridge. Those can be used to get you within a certain range on the pH scale. So if bromothymol blue is yellow, things are likely to be acidic. But when it comes to saying how acidic or how much H+, we just can't do it. So pause with any questions, whether it's on how to use table M or acids and bases now. Otherwise, I'm gonna move on to how we can figure out the concentration of the acid itself. You know you have a certain volume sitting in your beaker on your desk right now. So we know the volume of acid. And one thing you also know, if you messed around with the baking soda at all, bases neutralize acid. Which is to say, the OH minus of the base is going to neutralize the H plus of the acid to create H2O. And if you want to look at a sample reaction of that, let's take our hydrochloric acid and combine it with a base from table L, KOH. What we're going to see is this H plus neutralize the OH minus to form HOH, aka H2O, aka water, something totally neutral. And then I'm just going to rate whatever I have left over, my positive thing first, followed by my negative thing. And there you have a neutralization reaction. What's going on when we mix together an acid and a base? And that's exactly what you're going to be doing today in order to figure out the concentration of acid when you don't know how many moles you put in the first place. We're going to take advantage of this fact that when I mix together acid and base, those OH minus ions cancel out the H plus ions, and we end up with something neutral. This equation hopefully looks a little bit familiar, and it tells us just how much acid or just how much base is going to be required to completely neutralize its opposite. And remember, folks, this is the titration equation because it has to do with the process called titration, where we take a base or an acid to figure out an unknown concentration. Please, please, please remember, capital M does not stand for moles. Capital M stands for concentration. So if you see any reference to a 1.2 molar solution or a 1 molar solution, I'm not talking 1 mole, I'm talking 1 molar, moles per liter. So don't get that capital M mixed up with the concept of moles. And if this equation doesn't look so happy, check out table T. It defines each and every variable for you if you ever forget. Our concentration of our acid, volume of acid, concentration of base, and volume of base. And what this is telling us is we've got to add an acid of a certain strength to a base of a certain strength in order to cancel it out completely. So your task during workshop today is to figure out how to use titration in order to determine the concentration of an acid sample that's going to come around in the blue bins. So please, folks, be careful, follow appropriate safety procedures. You're going to have both concentrated acid and concentrated base on your tables today, so be on your best. And if you have any issues or any concerns, email me. I'm not going to be back today, but I will be around for homeroom and after school tomorrow. And if you have any free moments that you just want to drop by, please, please do, because this is important stuff. All about properties of acids and bases, how we define them, how we can figure out if it's acidic or basic, and of course now how to use the math to back it up to figure out concentrations. Good luck today, be good, and I will be back for you tomorrow.